So, one final technique which I want to introduce yourselves to when you're dealing with integration. Okay? Then we'll do a little summary at the end. Okay, so this is the idea of integration by parts. So if you remember, integration by substitution, that was the first thing we did. Okay, integration by substitution. So we literally let u equal the inside function, and then we just think what we need from there on in. Okay, so integration by substitution, that's kind of, it's got an equivalent in derivatives, hasn't it? What is that equivalent? So what's the equivalent of integration by substitution in differentiation? Would you be happy it's kind of the chain rule? Yeah, it's kind of the chain rule there. Because you let u equal something, then you have to find the derivative of that, and then you have to substitute it back in. That's literally the same idea as the chain rule. Yeah? So when you've got a function hidden within another function. Okay? So the equivalent of integration by substitution in derivatives is the chain rule. Right? Now just remind me, there were two other rules when we were dealing with, so there's another one. Okay, when we're integrating, when we're integrating like trigonometric functions or functions like this, okay, we knew that they were equal to that because we knew what their derivatives were. Okay, we thought about the derivatives. So saying, what function do I have to differentiate to get that? Okay, now we call that integration by recognition. Okay, integration by recognition. Simply by thinking, well, what function do I have to differentiate to get that? I can work out what the integral should be. Yeah? Hence how I got from there to there. Okay? Or hence how I thought about the integral of trigonometric functions. Okay? So integration by recognition, that's really thinking about differentiation. Now there is one other rule in differentiation that we haven't looked at with equivalence in integration. Can anybody think what it is? The product rule. Remember the product rule and quotient rule are the same thing, so really just the product rule, okay? And this is where the next thing comes in, which is integration by parts, okay? Integration by parts. Basically the equivalent of that in differentiation would be the product rule. Okay? Product rule. So, this is how it works. Can anybody remind me, what is the product rule? So just give it to me in differentiation. What is the product rule? So if I have two functions which I'm multiplying together and I want to find the derivative of them, what should that be equal to?
U to multiply with v derivative of v plus v multiply the derivative of u.
Perfect. Yeah? You happy with that?
Mm-hmm.
Okay. Now, let's have a think about this. I'm going to rewrite it slightly. So I'm going to write this as d dx of this thing. Okay, another way of rewriting it. So d dx of uv. Okay, that should be equal to u multiplied by dv, so d dx of dv, plus v multiplied by du by dx. Okay, and just for the sake of kind of completion here, okay, what I'm going to do is rewrite this, so multiply through by dx. Okay, just for the sake of simplicity. So get rid of the dx's in each thing. So I'm going to get d uv is equal to u dv plus v du. Yep, so I've literally just multiplied through by dx. Okay, it's just a fraction, so I can do that. Right. Now what I'm going to do is I'm going to integrate both sides. Okay, why not? So I'm going to integrate this thing, I'm going to integrate this thing, and I'm going to integrate this thing. Okay, so I'm going to integrate both sides. They're integrated with respect to x, because all of these function in terms of x, but just for the sake of simplicity, I'm just going to integrate both sides. Is this okay? Right? So, have a look. What's the integral of a derivative? Well, didn't we say that integration and differentiation undo each other?
Yeah.
They're reverses of each other. Yeah? So, in other words, if I have the integral of a derivative, this thing should just be equal to uv. Happy? They just cancel each other out. Integration, differentiation, cancel each other out. Okay? And then I get the integral of u dv plus the integral of v du. Okay? Now, would you be happy that I could take this thing over this side? Yeah? Just by subtracting it from both sides, just solving an equation. So in other words, I could say the integral of u dv, that thing there, should be equal to that thing, uv, minus that thing, the integral of v du. Happy with that? Yeah? What I have here is a way of integrating the product of two functions. Because if I say the integral, if one function is u, the other function is the derivative of v, then I should be able to use this idea to work out what that should be. Is that okay? Yes. Yeah? So as an example then, and we'll only have time to go through an example today, but I want you to try these in your own time as well. Let me write this over on this side of the board so we've got it. So the integral of u dv should be equal to uv minus the integral of v du. That's my idea. So let me get rid of this. Here I have the integral of a product of two functions. Okay? Here's one function, here is another function, and they're being multiplied together, hence product. Okay? Hence I think this would satisfy it. This would satisfy it. Okay? So let's have a look at this. I need to let one of my functions be u and one of my functions be the derivative of v. Now, as a general rule of thumb, try and find a function which you think is easier to differentiate. So is this one or this one easier to differentiate? First or second? Blue or red? I'd say the blue one. So in other words, I'm going to let u be that one. Okay? So I'm going to let u equal x. Now, if you have a look on the right-hand side of the formula, I have the derivative of u. So what would the derivative of u be? Let's do it now. Just 1. Perfect. Okay? Now have a look here. Okay? Because I've let u equal that one has to be the derivative of v. In other words, 2x minus 3 all raised to the power 4. Okay? Now if you have a look on the right-hand side, I need a v. I need a v. So if that's the derivative of v, what's v going to be?
Want to delegate the $8 an hour agent?
What's v going to be? In other words, if I need to get from the derivative of v back to v, what do I need to do?
So
I need to integrate. So let's have a think. We have looked at how to integrate functions of this type. See if we can remember it. Okay, how do we integrate functions like that? Yeah, good. So you need to effectively use the integration by substitution. So you need to let u equal that, and then you can go through the substitution. If you're quick at this, and maybe you've noticed a few patterns, it's effectively the chain rule in reverse, isn't it? It's effectively the chain rule in reverse. So, does anybody feel brave enough? What could this be equal to?
4 multiplied by 2x minus 2 over by 3 multiplied by 2.
That would be the chain rule. So in other words, if I differentiate it. The only difference now is because I'm integrating it, instead of multiplying by the derivatives, what should I do instead? Divide. Yeah, I should divide by the derivatives. Yeah. So let's have a think. Does anybody feel brave enough? What should this be equal to?
So 2x minus 3 over power of 5.
Yes.
Divided by 5.
Yes.
And also the 2 multiplied by 2.
Good. So you need to divide by the 2 as well. You need to divide by the derivative of what's in there. Now again, if you didn't quite follow that, it's fine to use u equals this. Okay, but I'm effectively just thinking about the chain rule in reverse. Okay. What am I missing?
Plus c.
Okay, plus c. So I should have a plus c here because, strictly speaking, I'm integrating. Okay, let's have a look at this. So we know that the integral of x times by 2x minus 3 all raised to the power 4 with respect to x should be equal to u multiplied by v, which is going to be x multiplied by this thing, okay, multiplied by 1/10 of 2x minus 3 all raised to the power 5, yeah, minus the integral, well, let's have a look. It's going to be the integral of v du. Make sense?
Yes.
Okay, good. So it's going to be the integral of v, which is 1/10 of 2x minus 3 all raised to the power 5, times by the derivative of u, which is just going to be 1. Does that make sense to everyone? Yeah? Does that make sense? Okay, so let's have a look. So we could tidy this up slightly. So we get 1/10 of x times by 2x minus 3 all raised to the power 5. Okay. I could pull a 1/10 out here. What would the integral of 2x minus 3 all raised to the power 5 be? What would the integral of that thing be? Have a think about what we did up here. Okay, so we've got 2x minus 3 all raised to the power of 6. What are we going to divide by? Yeah, 6 multiplied by 2, which equals 12. Now I put my plus c in, okay? So I didn't bother about putting the plus c up here because I knew that the plus c could come back later on down the end. Okay, I don't have to worry about it. Make sense to everyone?
Yes.
Cool, fantastic. So here we go. So we get, I guess I could do a bit of factorising actually, because I see a 2x minus 3 all raised to the power 5 in both. So I could take out a 2x minus 3 all raised to the power 5, and I could take a tenth out of both of them as well. Hence, inside the brackets, I'm just going to be left with x, because that's gone, minus 1/12 of this thing, and then plus c of all of this thing. That's fine.
What's that? We left off the dx at first equation. 2x or minus 3 over 5 multiplied with.
Multiply by 1, because it's just the du.
Oh yeah.
Yeah? Cool. And then actually I could tidy this up slightly because I get x minus x over 6, don't I? So x minus x over 6 is going to be, let's think, about 5. X minus x over 6 is going to be 5/6 of x. Okay? And then I'm taking away a 12th of negative 3, which is going to be the same as adding a quarter. Happy with that? And actually, I could probably pull out another half as well, I guess. So I could change that to a 20, that to a 3, and that to a 2. But don't worry about simplifying it all the way down. If you want to leave it to there, that's fine.
Why there's no column?
Why is there no bracket? I don't need to at this stage, because here I'm just simply applying the integration by parts formula. Okay? So effectively, I'm just dealing with that bit there, which becomes this. Yeah? It's only later on when I'm saying, hang on a minute, I know it's a factor of this, a factor of this, and I've just factorised that out to end up with this. Is that okay?